Alright, here's a fun application of physics. Ballistics, figuring out how fast a bullet was traveling. So for this problem we work backwards. So this drawing represents a bullet that has been fired into a wood block hanging that's like a pendulum, and that pendulum with the wood block and bullet on the bottom has swung up a bunch. So when that wood block got hit by the bullet, it was down here, and it had its potential energy increased as it raised in height. So the process of this pendulum swinging up was just a conversion of the kinetic energy that the bullet and wood block had into potential energy. The instant after the bullet goes in the block and bullet have a velocity moving this way, and we want to figure out what that was. That velocity is entirely converted to that velocity is entirely goes down to 0 by the time the bullet and block get up here. So all that kinetic energy that the bullet and block had is turned into potential energy. So we can set up an equation: the potential energy at the top equals the kinetic energy at the bottom. And let's plug in some variables. We know the potential energy is mass times acceleration of gravity times height, and the kinetic energy is half mv squared. That h height is really the difference in height. So if we started here and we ended up here, this distance is our h, our height. And for this problem, let's say we are trying to figure out a general expression for how to figure out the velocity of a bullet coming in. So instead of writing a certain number for the mass of the block and a certain number for the mass of the bullet and a certain number for the height here, let's just solve these equations leaving in the variables so that anybody who does a ballistics test can apply the equation on any type of pendulum they're using or with any different mass of bullet. The first thing we want to do, like I said, is solve for this variable v here, because that'll get us one step closer to the velocity of the bullet. This velocity here is the velocity of the bullet plus block. And let's go ahead and solve for that. These m's cancel out. I'm going to multiply both sides by 2 to get rid of the half. So we get 2gh over here equals v squared. But we don't want to solve for v squared, we want to solve for v. So we take the square root of both sides. And that's our definition for the velocity of the block and bullet together after the bullet impacts. Why is that useful to know? Well, because now we can continue working backwards and think about that collision. What do we know about collisions? Well, we know that momentum is conserved in a collision. So the momentum of the bullet before it hit the block must be equal to the momentum of the block and bullet together after the collision. And let's assign some variables. The mass of the bullet is going to be somewhat small compared to the block, so we'll call that little m. And the block is bigger, we'll call that mass of the block big M. And we need some way to signify that the velocity we've been talking about so far is the velocity of the two masses together. So we're going to call that v prime, like in the slide. And then we can just call the velocity of the bullet, we can just call that v, without the prime. So the last thing we have to do now is set up an equation based on the conservation of momentum in this collision, and then solve that equation for v. So we know that momentum of the bullet plus block system before equals its momentum after. The momentum before is both the momentum of the bullet, mv, plus the momentum of the block, which isn't going anywhere, so it's really 0 because its velocity is 0. I'm going to go ahead and put 0 instead of v. So that's the initial momentum of the bullet plus block system, and the final momentum is the mass combined of the bullet and block, little m plus big M, times the velocity of the bullet and block together, which we called v prime. Alright, let's go ahead and solve for v. We know that disappears because it's just 0. All we need to do is divide both sides by little m. And we don't want to leave this in terms of v prime because it's hard to measure that. Because v prime is the velocity of the block and bullet the instant after the bullet hits it when it's going the fastest. So let's put in our definition of v prime with variables that we can measure. We always know g, 9.8, and the height is something that's pretty easy to measure physically. So that would make this a more useful equation. Alright, so here's where I'm going to insert this definition of v prime. I'm going to replace v prime with that square root of 2gh. And there's our general equation. And there you have it. Here's an equation you can use for any test you do. You just put in the mass of whatever bullet you're using, the mass of whatever block you're using, the mass of the bullet again, the acceleration of gravity, always 9.8 if you're on Earth. You can even do this on the moon, put in the acceleration of gravity on the moon. And that's just the height that the pendulum gets raised.